Hi, and I'm not doing the amazing work, it's a team. So I work for NASA, and let's get going. I am a software engineer, I'm not a computer scientist, and I've been at NASA for 2 years, and I was a contractor before that. So my current job is with unmanned aerial vehicles, and everybody out there knows what drones are. And I have a question for you. So what would you do with a drone if you had one? Or what do you think they're good for? That gentleman down there? Say it. Aerial photography. Excellent. Anybody else got, what would you do with a drone? What do you think they're good for? Yeah. Send messages to other people? Oh, you would deliver messages to other people using the drone? Cool. That would be a good case. Over here? Yeah.
Make videos with them?
Right. It's amazing what they can do. They're not jiggly and so forth. Make videos.
Oh, spy on people?
Excellent. And that is an issue we'll cover. So surveillance. Surveillance that is cooperative and uncooperative.
Check on people who are in trouble?
Excellent. So one of the use cases that they are good for is surveillance in emergency situations. Do you think we're going to have like ambulances that are little drones? Yeah, we will. More?
To see the planets in outer space.
To visit a planet in outer space. That would be creative. Yeah, I'm sure that once we get to Mars, someplace that has a volume we could fly in, they could go there. Yeah. Yeah.
Like a solar panel on it, and it would like stay charged all the time. It could just like surveillance system around your house.
Oh, so you would power the vehicle using solar power?
Panel.
Excellent idea. That would be, because power is a huge consideration. In fact, probably the #1 consideration for a pilot to make sure that it's up in the air with power. Let's go. So we will start out with package delivery from Amazon. So this is already happening some places around the world. Google's in the market. Lots of companies are in the market. This is their fulfillment center where they gather all their materials. NASA is working with the commercial entities that are flying drones right now, and that's what my job is, to get those commercial entities together and agree on how to be safe. So Prime Air is the subdivision of Amazon doing that work. And we work with about a dozen different companies. Should I take questions at the end or in between? At the end? Okay, we'll do it at the end. Okay, let's keep going. But I'll get back to you. So they can deliver packages. This is future, but it's not far off. They can deliver people. And we have Uber right now, of course. So Uber has found that they're good for short trips I mean, it could hop in the car and go a few miles. But going across town, 35 miles, 25 miles, not so good. It takes too long. And so they're going to be flying. And these are robotic, pilotless vehicles. And they will be landing on vertiports. So this one shows a woman coming home from work. In LA, they're going to have this in like the next 5 years, they say. Uber says. That's a vertiport. So these hold 4 passengers, and they do not have a pilot. That's the remote pilot. So you young folks, I'm just wondering, would you want to fly in a vehicle like that? Who would want to fly without a pilot? Just curious. Does it freak you out? So the first few years, they will be piloted, but they will be robotic. They will be remotely controlled. This is what Uber says. This is not the work I do. What we're doing, I'm getting to it, but a little bit more about my background. So as I said, I'm a software engineer, and I like to make things. So my first job was a long time ago when robots first came out. And the first applications were putting cars together using welding. And I looked at that, and I was pushing paper, but I wanted to be somebody who was actually doing the work and producing things, making things. So at NASA, I spent time on the space side of NASA. NASA has Aeronautics, which is about airplanes, and space, which is about outer space. So I've been on both sides. My domain knowledge is in computing. It is not in aeronautics, and it is not in space. But the main knowledge refers to the context of which you are working. So although I know a lot about computing and how to put apps together, I had to pick up with each job that I had, with the welding job. I was with Hewlett-Packard with a online banking application, and now I was with space side on NASA. So you have to gradually pick up your domain knowledge enough to do your job, and sometimes more. So along the way, I made some mistakes. The first one is I didn't keep up with the tech at one point. So you're a mom, you're raising 2 kids. My husband and I have 2 daughters, 23 and 25. And when they were young, I was running around with kids, and you get distracted. And so I don't think I kept up with it as well as I should have. And it moves very fast. As you know, the technology can change every 6 months for some technology stacks. And I wasn't focused enough. So the solution I found for that was to not volunteer too much in the schools, to have a balance, and to give myself a 4-hour block of work time. Shut off the cell phone, shut down, because when you are coding, you need to focus, or I need to focus. Getting distracted is not efficient. So negative self-talk is when I was trying to keep with the technology, I felt intimidated. And I remember sitting in a classroom, for example, with a bunch of people guys and women, mostly guys. And then the instructor said, okay, let's bunch up and do some labs, so let's couple up. And I was sitting there, and it's like being the last person being picked in a ball game. And you know, those 3 guys were over there, and those 2 were over there, and finally I did pair up. And this was a class that went for several weeks, well, a dozen weeks. And as time went on, I realized, I know just as much, I know more than most of them, because you know, I've been around. So I didn't know about that particular topic, but in general, I knew a lot. And so what I want to emphasize is that everybody comes from a different timeline. Everybody comes from a different background. And we all walk through life with what we have at the time. And the other thing is technology moves so quickly that no matter how much you know, you're still not going to know a lot about a lot of things, but you could learn. So negative self-talk, it's going to happen, and feeling intimidated is going to happen because you're always learning new things, but you'll get used to it, and you'll be able to learn quickly. What's really exciting is when I got to the point in certain areas where I could start giving advice, giving technical knowledge to other people. And that's where I felt like, wow, I like helping people. I like being an expert in certain areas. And as time went on, that began to happen. So in other ways that I solved my mistakes is, as I said, I took classes. I built an app on Android, and it was a little fun game for my family. I also got involved in Women Who Code. So it's a lot like Black Girls Code, except it's a professional organization for women. And I got outside of my area of my coworkers, outside of my company, met a lot of people. I got a perspective on things, got a lot of support, made some friends. So that's another piece of learning that I would share, that if you have an opportunity to, in school maybe, take clubs, go to clubs, spend time with other people, you learn a lot more by coding together with other folks than you do when you're coding alone. And it also helps you keep up with the technologies, because you hear about new things. So, aeronautics, when I first walked into that job, I didn't know anything. So the domain knowledge has to do with how do you fly an airplane and how do you fly it safely, how do you fly it efficiently, and I'll get to the fairness in a bit. So roll, yaw, and pitch is a basic aeronautical term which I know nothing about except this diagram. The scientists I'm surrounded by will study things like how does wind affect the flight patterns of a vehicle. So years ago, obviously, there were only manned vehicles, but there have been 2 categories, the fixed wing and the rotor. Nowadays, in the last couple of decades, the unmanned aerial vehicles came into play. There are large unmanned vehicles, as I showed you with the Uber, and then there's a class of vehicles that are 50 pounds and under and fly in elevation that's 500 feet or lower in the skies. And with those also there is fixed wing and rotor. And so a piece of domain knowledge would be what are the pros and cons of fixed wing? And what are the pros and cons of rotor? So does somebody want to just take a guess? Back there? If the vehicle's small, it could fly higher? It could fly away if it's small. Oh, with the wind? Right, with the wind could push it out of its path if it didn't have enough power to compensate for that. Yeah, so you could hypothesize whether a fixed wing would be better at staying on its trajectory, at the flight path, or whether a rotor would be better. How about for package delivery? What do you think is better for package delivery? Rotor is better because the fixed wing, they can actually fly faster and longer, and they can stay in the air longer, but they're not going to be able to hover. And so for gently putting down that package, you would want to be hovering. So of course, helicopters or rotor are better at that. Yeah. One more?
Wouldn't rotor be, wait. Okay. Wouldn't bigger be better?
Bigger would be different. Bigger would, I'll get to that in a second. It's a good question. There are classes of vehicles, and they are regulated by the class size. So the class of vehicles that I am dealing with are 50 pounds or less. So they can be pretty big at 50 pounds. It's amazing how large they can be. However, the better is a relative term, and that's what the scientists that do at NASA, they study the whole domain and say, well, what does it mean to fly with a fixed wing with this kind of wind conditions or ice conditions? So the bottom line is for fixed wing versus rotor, fixed wing is more fuel efficient. It can go faster and stay in the air longer, and so forth. I don't know a lot about it, but that would be the domain knowledge. So as I touched on before, countries in the world regulate their airspace. And the regulation can be done by a government entity or a commercial entity, a company, or both. And most nations in the world regulate their airspace by at least a government agency, sometimes in conjunction with a commercial entity. And the objectives of me and the people I work with at NASA, we are a public entity. We represent the government of the United States. We have to make sure the skies are safe. That's fundamental. But we also want to promote good business in the United States. So we want to make sure that the airports are available for airlines to fly from. So for manned flight, we regulate well, I don't at NASA. So the government agency that does for the United States is the Federal Avionics Administration. It's called the FAA. And the FAA has certain laws, and one of the laws is if you have an airport, you can't just have one company flying there. You can't just have United Airlines being the only company there. And no, you have to share it. It's a public resource. The air that we are in and the volume of air that the vehicles fly in is a public resource that we share. And we have to do it fairly. So yes, we want companies to do well and make money, but we also want to do it in a fair way. We don't want to have one large company getting most of the business. We want to make sure that the infrastructure and the rules surrounding it support small businesses too. So some more use cases are, as this young woman pointed out, surveillance. We've got here manned flight. We've got agriculture. I'll hit on a few in the next few slides. In regulating the airspace, people who are pilots would know this. So it's divided up into upside-down wedding cakes. And if this was San Francisco Airport, there is an upside-down wedding cake over it for the volume of air, which restricts other other vehicles from entering that volume of space. So in this case, it's a 3D volume of space. And you can imagine why it's bigger at the top, because the large jets that are flying at 10,000 feet above the surface of the Earth, then they're coming in with their flight pattern, and then they have to land. So it's a larger volume up there because they're coming in for their takeoffs and landings, and a smaller area down there. But if you owned a drone, you cannot fly that drone, the FAA regulates this, within 5 miles of any airport. Now, there are ways to get exceptions. So if you're going to be taking photos of a wedding and you're 4 miles near that airport, you can apply for an exception with the FAA. So Airspace is where you would actually fly some vehicles. If you owned a drone, you could fly there without any authorization. So the FAA, through the decades, saw that, well, holy cow, we're going to have a problem. There are many drones. And actually, 5 years from now, there are going to be 4 times that many drones out there. How do we regulate it? So they asked NASA to help them figure it out. So the project I work on, like I said, is lower than 500 feet. Some of the aspects we have to think about is how much buffer zone. So if the wind is going to fly out of your planned volume, how much play area, how much extra space should you put around it? So that's called a conformance region. So usually you plan your flights so they're 400 feet or lower. So if you do get blown out, you're not going to go past the 500 mark. We think about altitude, and there are several ways to define altitude. So we define data standards to make sure that everybody's talking in feet and not meters, or vice versa, so that they communicate precisely what their altitude is. And we think about terrain. So there are terrain maps that you can download that will show you where you might bump into a building. And we think about flying through small canyons safely. Another application, as somebody pointed out, is safety. Safely inspecting a scene of an accident. Here you have a car accident, and the cars are pulled over here, but if they weren't, it would be quite dangerous to go in and try to inspect that. So yes, they have to come in and help the people who are in the accident, but they also need to have aerial surveillance to inspect it. So drones are very good at doing use cases that are dangerous for a human to do. And agriculture is actually a significant use case. So this shows not only agriculture, but how you communicate to the vehicle. So here you have what's called the ground control station, which in this case is a tractor, but it could be you sitting there with your laptop or you with your cell phone. And you're doing radio signals to control the vehicle, and that's called COM2. So when I tell a vehicle, I'm commanding it. So COM means command. I'm telling it, okay, go up, go down. And then the other one is COM1, where the vehicle is telling you where it is. So it will know from GPS what its lat long is and send back down to you where it is. Because most flights for commercial are beyond visual line of sight. The pilot cannot see the vehicle. It's all remote. Now, we're used to these fancy use cases that I showed in the beginning, but actually, a scientist from Papua New Guinea worked with us this summer. I didn't know this, but Papua New Guinea has 600 islands and thousands of languages, and it's very underdeveloped. It's called low infrastructure because they don't have roads, and even if they had roads, you've got to get to an island. So the island can take hours and hours to get to. It's a pretty spread out location. That's a large geographical area. So one of the use cases the scientist is trying to do is just get immunizations to other islands, other people, other villages, and in Papua New Guinea, in her country. And so some of these immunization medicines that are given need to be refrigerated, and once they're out of the refrigeration, they only have a limited time, a matter of hours before they should be given. So you need a reliable, fast, easy way to deliver medical supplies. Another concept that, this is future, but it's actually part of what we're doing today. Flight planning is done in terms of well-known highways in the air. And so, especially as they get denser, in a dense urban situation, there will likely be flight skyways. And as I showed earlier, vertiports between those skyways where the traffic will go. Now, these drones are going to separate themselves typically using altitude separation, or they can use time separation. Because when we plan the flights, it's called a four-dimensional volume or a 4D volume. So when a company says it's going to be flying that drone in a particular location, then it'll specify what time it's going to start, what time it's going to end, and the 3D volume of space, which is done with altitude and longitude and latitude. So those are skyways. And this is kind of now and future. Again, back to delivery or many use cases. The last hop is an issue. So you can't just fly to anywhere and deliver a package. More than likely, there will be several hops. So this is showing a concept where the vehicle actually is the launch pad for the takeoff and landing of a drone. And it's showing that, so the drone would fly the large distance to the vehicle would drive inside the city to the human, and the human would take the package and deliver it to the front door. So what could go wrong? Now, I asked you what they could be used for, but what can go wrong? 2 more minutes? Okay. Lots of things can go wrong. They could crash into each other. They could crash into a manned vehicle. And they could crash into terrain. But one aspect that actually I'm more involved in is security. So when I was at Hewlett-Packard, I did online banking applications. And one of the concerns, if you log into a bank, for Wells Fargo, for example, is I don't want people to see what I'm sending. I don't want them to see my account number. How do we deal with that? How do we prevent a man in the middle or somebody from seeing the data that I'm sending? In drones, there can be the same similar kind of effect. If an attacker intercepts the signal, they can spoof it. That's called spoofing. So here we're showing that there's a vehicle, and it's going to go on the blue path, and it thinks it knows the lat long, but the lat long is actually a fake signal that the attacker has generated. How do you make sure that that doesn't happen? So you can encrypt the message. Encryption is just scrambling a message. You have a key, and you have the original message, and you're making it into a secret message. Now here's a very simple method where you take the alphabet, 26 letters, and you shift it by 13 characters. And then you substitute in the character for the character that's in the 13th position away from it in the alphabet. And then you rotate the alphabet through. Now, this primitive method of encryption was used thousands of years ago. But nowadays, we have very sophisticated methods of encryption, and security is dozens and dozens of things more than just encryption. But this is one tiny aspect. And so nowadays, you would encrypt it using a public key and a private key. And with those kind of protections for the data exchanges that go between you and the vehicle, and from, for example, Amazon to Uber, those communications will be private and protected by these keys that sometimes they're secret keys, and sometimes they're the public-private keys. So we care deeply about protecting ourselves from attacks. And that is the end. I want to say that, again, my team has contributed a lot of material for this. So some of these slides were from my coworker, Jay Wu. And so let's go to questions.
All right, let's give a big round of applause for Irene. All right, so we have time for about 2 questions. And don't worry, she's going to be with us through lunch, so you can ask her all the questions you want then. But we have time for 2 questions now.
Hi. Do you guys use Edisons to deliver things?
Use what?
Edisons.
I don't understand. Edison's?
An Edison is like a robot or whatever.
Oh yeah. So remember I showed you the last hop? So there are little robots. They look like actually wagons. I have a picture somewhere. But the drone would fly it to this little wagon, and the wagon it's a robot, would go like in the city street to the building and take it to the restaurant or the front door, wherever that destination is. Yes?
Like DoorDash?
Pardon?
Never mind.
Okay, question?
All right, and we've got one over here.
Yeah.
You didn't get to the spying on people part.
That's a good one.
So could you spy on people with these things? Like if you were a hacker trying to see their information?
Yes.
Not saying that I'm a hacker or anything. I'm just saying. Like if
Yeah.
you were a hacker, could you like take one of these drones? Like if they were that advanced where they were like super, super quiet.
Then
they just hover over you while you're looking at your credit card or bank
Yeah.
information.
So the way you could do that is you could use spoofing. So if I was flying maybe to a company to deliver something, I trust that my vehicle is the same vehicle that I think it is, and it has an ID number to prove that it is. I also trust that it's called the payload, so the camera that's hanging onto the vehicle is a payload. I trust that my payload hasn't been spoofed. And to do so, I use strong authentication, this is a security term, to prove that exactly that vehicle with exactly that ID. It's like proving that I am Irene. You do that with things too. So everything has an ID, and that ID is able to prove, is one way with certificates and other aspects of security to prove that that vehicle that I'm flying is mine, that camera is mine, and the control system is mine, and all of those factors. But it's a big problem space, and we worry deeply about those kind of attacks.
All right, let's thank her once again for that awesome talk.